Good day, grade 8. I am your teacher, Marie.
Good day, grade 8. Now, we're going to discuss a new topic. Let us enjoy watching while learning. So last time, we have discussed theorems on triangle congruence. Now, let us discuss theorems on triangle inequalities. So, triangular shapes are common everywhere. From building design to playgrounds, amenities, triangular objects are typical fixtures. In fact, triangularly shaped structures regarded as most stable design. So equality or inequality, which do they think is more important, such as the word means being in the reality of life? If you observe the word, you can determine that there are many aspects in our life that are not equal. Every individual has its own identity. That's why each of us is unique. So, there is an equality or there is inequality. We already discussed the congruence in triangles and identified the different theorems on how we can prove its congruency. But not all triangles are congruent. So what are those theorems in triangles inequality? So first is the exterior angle theorem 1.1. This is the measure of an interior angle of a triangle is greater than the measure of either its corresponding remote interior angles. That will be the interior angle inequality theorems. Angle A and angle B are the remote interior angles. Take note, the remote interior angles can be seen in the same side of the triangles, or the angles are corresponding in one side. Then, in the outside or the interior angle, so the base that we have AC, the line extendedly to outside. Therefore, there is angle formed, and that will be the interior angle, and we have the angle D. So an interior angle of a triangle is an angle which is adjacent and supplementary to one of the interior angle of a triangle. So the remote interior angle of a triangle are the interior angle not adjacent to given interior angles. The measure of interior angle of a triangle is equal to the sum of the measure of the remote interior angle of the triangles. So let us prove the triangle ABC and the adjacent AD. Since the sum of the interior angle of a triangle is equal to 180, the measure of angle ACB plus the measure of angle A plus the measure of angle B is equal to 180. So the angle A plus the angle B, the remote interior angles. Also, we have the measure of angle ACB plus the measure of angle ACD is equal to 180 because the two indicate that the angle form a linear pair. From those two statements, we obtain that the measure of angle ACD is equal to the measure of angle A plus the measure of angle B. So, we can say that the angle ACD or the interior angle formed outside of the given triangle that we have is equal to the remote interior angles. So since the measure of an angle is opposite number, we must have the measure of ACD is greater than the measure of angle A and the measure of ACD is greater than the measure of angle B. Let us have an example. So example number 1, in the given triangle ABC, angle BCD is interior angles. So if the triangle have the angle BCD is equal to 127 degrees, then the measure of angle A is less than the measure of angle BCD, and the measure of angle B is less than the measure of BCD. Another theorem is the exterior angle theorem 1.2. The measure of the interior angle of a triangle is equal to the sum of the measure of the two remote interior angle. This will be the angle that I said last time that if we have the interior angle, it is equal to the two remote interior angles that we have in the given triangles. So examples, find the measure of the indicate angles. So the number one example that we have, the measure of angle P is equal to 34. Then the measure of angle A is equal to 85. And the measure of angle AST is unknown. Then we have to find the measure of angle AST. So the measure of angle AST is equal to the measure of angle P and the measure of angle A. It is proved by the exterior angle theorems. Therefore, if we have the measure of angle P is 34 and the measure of angle A is 85, let us add the two. We have 119 degree. Therefore, the measure of AST is equal to 119 degree. Now, let us have another example, number 2. We have the measure of angle AST is equal to 97 degree, or the exterior angle is 97 degree. Then the measure of angle A is equal to 74 degree. And the measure of angle P is unknown. Here, the other one remote interior angle is unknown. First, we have the measure of angle P plus the measure of angle A is equal to the measure of angle AST. So, angle P plus 74 degree, that we have the measure of angle A is equal to 97 degree. Transpose the 74 to the right side, it becomes negative 74. Therefore, 97 degree minus 74 is equal to 23 degree. Therefore, the measure of angle P is equal to 23 degree. Number 3, we have the same given figures. So, angle P is equal to x plus y, x plus 6 degree. And then the measure of angle A is equal to x plus 12 degree. Then, the measure of angle AST is equal to 2x minus 4 degree. Find the measure of the three angles. So, first, let us find the value of x. So, here we have the measure of angle AST is equal to the measure of angle P plus the measure of angle A. So 3x minus 4 is equal to x plus 6 plus x plus 12. Then combining like terms, so we have 3x minus 4 is equal to 2x plus 18. Then transpose the 2x with the variables x in the left side and the constant negative 4 to the right side. Therefore, we have 3x minus 2x is equal to 18 plus 4. Then, we have x is equal to 22. Now, let us substitute the value of x in the given angle that we have. So, the measure of angle P is equal to x plus 6. So, x is equal to 22 plus 6 is equal to 28. Then, the measure of angle A, we have x plus 12. So, x is 22. Plus 12 is equal to 34. So we have the measure of angle AST is equal to 3x minus 4. So the value of x is 22 times 3 is equal to 66. Minus 4 is equal to 2. Therefore, the measure of angle P is equal to 28 degree. The measure of angle A is equal to 34 degree. And the measure of angle AST is equal to 62 degree. To add the two remote interior angles that we have, so 28 plus 34 is equal to the measure of the exterior angle 62 degree. So, theorems of inequalities for sides and angle of a triangle. So here we're going to discuss the theorems of inequalities for side and angles. So congruency in triangle is not the only intersecting property of triangles. The inequalities of side and the angle of triangles have fascinating characteristics as well. Consider the triangle ROD in the right side figures. What do you have? What observation did you find? What is the relationship of each side, so they're opposite angles. In the figure, side RO is opposite to the angle D, and side OD is the opposite of angle R. Side RD is the opposite of angle O. From the figure, we can say that segment RD is greater than to segment RO, and RO is greater than segment OD. Same with angle O is greater than angle D, and angle D is greater than angle R. So we have the unequal side theorems. So if the length of the side of the triangle are not equal, the angle opposite their side are also not equal. The larger is the opposite, the larger the side. So if we have the larger angle, the opposite side of it has the larger side. So it is the angle opposite longer side theorem. So if one side of a triangle is longer than another, then the angle opposite the longer side is larger. So here let us prove that the larger angle have the larger side. Let us consider a triangle ABC with a segment BC is greater than AC. We will show that angle ACD is greater than angle B. First, let's locate D on RD such that CD is congruent to CA. So here is the proof. We have segment CD is congruent to CA by constructions. Triangle ABC is isosceles triangle. Definition of isosceles triangles. Then angle 1 is congruent to angle 2. Isosceles triangle theorems. Angle CAD is equal to angle 1 plus the measure angle of DAB. Angle addition postulate. Then angle ACD is less than angle 1 stated in the statement 4, and the measure of the angle is positive. So angle CAD is greater than angle 2 said in the statement 3 and 5 by substitution. Then we have the angle 2 is greater than angle B. We have the exterior angle theorem applied to triangle ABC. And then we have the angle CAD is greater than angle B statement in statement 6 and 7, and it is used by transitive property. So let us have an example. So in the triangle CHA, CA is 15, then AH is 9, and CH is equal to 18. Which is the larger angle, the smaller and the smallest angle? So the answer here is, since side CH is the longer side based on the given, then the larger angle is the angle opposite the side. That will be angle A. While the smaller is the angle opposite side, we have AH. So that will be angle C. It said that angle C is the smallest angle and the larger angle is angle A. An equal angle theorem. If the measure of the triangle of a triangle is not equal, the side opposite angle are also not equal. The longer the side is opposite the larger angle. So if we have the longer side, the opposite larger angle has it. So it is the side opposite greater angle. So this will be the reverse of the first theorem that we have. If one angle of a triangle is greater than another, then the side opposite the larger angle is the longer. So let us have an example. If a triangle BEL, the measure of its angle are follows. So we have measure of angle B is equal to 45 degrees. The measure of angle E is equal to 70 degrees. Then the measure of angle L is equal to 65 degrees. Determine the longest side and the shorter side. So here, the measure of angle A is 70 degrees, therefore it is the larger angle. Then the longer side is the opposite that angle it is. So we have the side BL, while the shorter side is the side opposite the smaller angle. Then the smaller angle that we have is the angle B, which is 45 degrees. Therefore, the opposite side is the shorter side. We have side EL.
Thank you. Enjoy watching while learning. This is your teacher, Miss Marimar F. Figalan.